Welcome to my channel. My name is Shobha. I am studying in Sri Venkateswara College of Engineering, Department of Information Science of Engineering, subject Applied Physics, section Ether. In this video, I am going to explain about matter waves and its properties. Introduction. Matter waves are a manifestation of the wave-particle duality principle in quantum mechanics. Traditionally, particles such as electrons and protons were viewed slowly as discrete entities with defined position. However, matter waves introduce a new dimension, suggestion that these particles also exhibit wave-like behavior. In simple terms, matter waves implies that particles traditionally thoughts of a tiny localized object can also display characteristics akin to waves such as interference and diffraction. This integration concept fundamentally alterates our understanding of the building blocks of the universe, adding a layer of complexity that universe the profound nature of quantum relativity. Wave-particle duality. Wave-particle duality purposes that particles such as electrons and photons can exhibit both wave-like and particle-like characteristics. This means that under certain circumstances, these entities traditionally thought of discrete particles can also behave like wave and with specific frequencies and wavelength. The implication of wave particles duality becomes evident through experiments like the double slit experiment, where particles, when not observed, create interference pattern types of wave when observed the behavior like discrete particles emphasize the dual nature of matter. De Broglie wavelengths. The de Broglie wavelength lambda is measure of the inheritance wave-like properties of a particles. It is calculated using the formula lambda is equals to h by p, where lambda is the de Broglie wavelength, h is Planck's constant, and p is the momentum of the particles. The significance of the de Broglie wavelength lies in the ability of to connect the particles and wave characteristics of matter. As particles gain momentum, their de Broglie wavelength decrease, highlighting the inverse relationship between momentum and wavelength. In simple terms, the de Broglie wavelength provides us with a tool to qualify their wave nature inheritance in particles. This concept becomes particularly relevant when exploring the behavior of particles on a quantum scale, where classically distinction between particles and wave blurs. Properties of matter waves, wavelength and momentum. The de Broglie wavelength lambda is inversely proportional to the momentum p of a particle. Lambda is equals to h by p. Higher momentum result in shorter wavelength, highlighting the wave particles duality and the interconnection nature of these properties. Diffraction. Matter waves exhibits diffraction, a phenomena where waves bend around, obstruct and spread out when passing through opening. This property is observable in experiments such as double-slit experiment, emphasizing the wave-like nature of particles. Interference. Interference occurs when matter wave overlap, leading to the reinforcement and cancellation of amplitude. Interference patterns are a hallmark of wave behavior and have observed in experiment with particles like electrons. Interference. Introduction to interference. Interference is a phenomena where matter waves combine leading to the reinforcement or cancellation of amplitude. This behavior in angularization to the interference pattern observed in classical wave statement double slit experiment. The classical example illustrating interference in matter waves in the double slit experiment when particles such as electrons are sent through too closely spaceship an interference pattern emerging on the screen behind, demonstrating the wave-like nature of particles. Quantum superposition. Interference arises from the quantum particles of superposition, where particles exist in multiple state stimulation. This leads to the formation of interference pattern when the state overlooked. Application of quantum computing. Understanding interference in matter waves is critical for from quantum computing. Quantum bits qubits rely on interference to perform complex calculation, showcase, showcasing in the particles of implication quantum phenomena. Application of matter waves. Quantum mechanics advancement. Matter waves play a central role in the field of quantum mechanics, providing a framework for understanding the behavior of particles on a fundamental level. Quantum mechanics, with this foundation in matter waves, have led to technological advancement and a deeper conference of the micro world. Microscope world. Electronic microscope. Matter waves particles, those are associated with electrons are harnessed in electrons microscope. The wave nature of electrons allows for higher resolution imaging, surprising the limitation improves by classical optics. Quantum computing. Matter waves contributes to the principle underlying quantum computing. Quantum bits qubits uh, leveraging the superposition and interference of matter waves enable the development of powerful quantum algorithm, algorithm for computation. Matter waves matter wave interferometric preservation measurement benefits for matter waves interference utilized interference pattern of matter waves enables precious measurement of quantities such as gravitation force and acceleration. Conclusion. From the interference pattern observed in the double-slit experiment to the application in electronics microscope and quantum computing, matter waves have proved to be more than theoretically crucial. They are the building blocks of our understanding of the quantum real, realm and the key to unlocking unprecedented technological advancement. Thank you.